Welcome to CppChat Take 2, and we're gonna start over and just remember everything we said. I think I remember saying something like the disclaimer this week is the views and I'm seeing.
All right, people can see us. Just let's keep going. Don't stop. We don't pick anything.
I think I had myself open another window. I'm sorry about
You're
that.
getting an echo. All right.
No,
Give us the disclaimer, John. Come on.
All right. Yes, I was distracted by listening to myself. Okay, so this week's disclaimer is the views and opinions expressed on the show are those of the individual guests and do not necessarily reflect the official policy or position of CppChat. And in fact, they may not actually be broadcast at all. So who knows? We're welcoming back a guest that we've had on before, and we have a new guest. So let's start with Jason Turner, who's been on the show before. Jason, let us know who you are and what you do.
I'm Jason Turner, which I think we just covered that, I guess, twice. I am an independent contractor and host of C++ Weekly and CppCast, and I guess a speaker at conferences and stuff like that. And I'm trying to compete with John for training.
There you go. And our other guest, for the first time, at least the first time on a full episode, is Matt Godbolt. Matt, tell us what you do.
So most people know me for Compiler Explorer, I think, which I'm sure we'll talk a little bit about later. But when I'm not hacking dreadful JavaScript together and duct taping compilers to web frameworks, I am working for DRW Trading, a trading company in Chicago. Prior to that, I spent 2 years, or just over 2 years, working at Google on some cool, interesting stuff for them, mostly to do with YouTube, ironically, because this is where we're having all the problems. For those who are wondering, if you're just watching this episode and you haven't realized why we're all laughing at each other, it's because we recorded 8 minutes earlier that seems to have gone into dev null, and so this is take 2. Anyway, before Google, I had my own C++ business doing C++ tools, which would be maybe some fun to talk about as well. And then before that, I spent 10 years making computer games for Xbox, PlayStation, PC, various different types of Xboxes, as discussed earlier in a... Oh my God. So that's me.
Well, I think it got fun when you were commenting that it was like pulling teeth to get hardware specifications from your tools.
That's right. So yeah, if those people watching the 8-minute snip, which it's according to the chat, people have found now on YouTube, so you can go back and compare and contrast the 2 different alternative beginnings to this show.
Usually people do alternative endings.
I know, but yeah, we like to buck the trend here. Yeah, so we were discussing about hardware specs and the fact that when you're writing for consoles, you, at least in the beginning days, the hardware specs were, here's a pile of manuals that tell you exactly how everything works. Off you go. No libraries, nothing. It was, you could write in C, you could write in assembly, you could write in C++ if you could find a compiler that actually worked back then. And you were responsible for poking the hardware in the right way, setting up DMA transfers and all very cool stuff, which is loads and loads of fun. And then by the time we got to, say, Xbox, and it was a much more PC-like system. I mean, it wasn't PC-like, but there you had an NVIDIA chip in there. We were discussing that the conflict starts to become with the IP of the vendors. They don't want everyone to know how their chips work, and so they want to layer over a set of drivers that try and hide the real way that things work underneath. Maybe also to allow for like revision changes of the actual underlying hardware as well, but yeah, we were pointed basically at a header file that had nothing more than sort of pound defines for all of the different DCD operations that actually just poked into a buffer that would then get sent over to the card. So you could kind of reverse engineer what it was doing, and that allowed you to do all sorts of interesting, cool things. Like one thing, this is completely now going off on a tangent, but one thing we discovered we could do is that we could set, so effectively it's like this huge buffer that's being DMA'd constantly over to the the GPU, and it contains a stream of instructions, like set these colors, draw vertices here, DMA from another place, and draw this mesh, or that kind of stuff, but very low level operations. But one of the things we could do is we could set it up so that it could point the render target as being like further on in its own instruction stream, and then we could render triangles whose shape just so happened to map exactly to the opcodes of its own instruction stream, so it could effectively write to itself and do self-modifying code as it was going. And the reason that was cool is because some of the operations could be like, draw this mesh. How many pixels did you actually draw? Oh, it was 0. Okay, well then let's not do any of this whole region. So you could kind of like draw areas of the screen and go, well, if that didn't actually amount to anything changing on screen, there's no point doing all the extra textures and all the special effects for that part. So there's all sorts of cool things you could do. Anyway, that's a complete tangent and got nothing to do with C++ whatsoever. But after we had spoken about this, I believe, Jason, you and I were just talking about, well, once we'd gone offline, how I loved C++ because it allows you to be both high level. You can build these giant castles of amazing sort of template metaprogramming, functional type techniques and stuff, but you can still keep going down and down and down and down until you're effectively at the assembly instruction level. And that is one of the most amazing things to be able to do with a modern programming language, to have both at the same time.
Yeah.
Someone else talk now.
Well, it sounds like you were just about to start talking about Compiler Explorer.
Yeah, I was just waiting.
We can certainly, yeah. So, I mean, that was one of the things that I found most interesting. So I guess the seeds for when Compiler Explorer, all the ideas behind it were forming.
We're all assuming that everybody listening to this knows what Compiler Explorer is, and that's probably true, but just in case.
Just in case. So
why don't you start at a little bit more of a tell us what the heck this is?
Is it possible for Matt to show his desktop? That would be awesome.
I dread to think what
you could hit screen share, but I don't know if it's worth the risk, actually.
I was going to say, given now, maybe next time we can do that. But yes, so Compiler Explorer is a website where you can simply enough just type in C code on one side, C++ code on one side, and see how it compiles into the assembly code on the other side, which allows you to get a little handle on what the compiler is doing, what kind of optimizations it's doing, what transformations happen to your code. What does it mean? How do exceptions work? I don't know. I mean, you can, but if you look at the disassembly, you've got some idea. It does some highlighting between the source code and the generated assembly, so you have a little bit of an understanding about, well, these lines of C code amounted to this add instruction over here. So even if you're not really that familiar with assembly code, you can get a bit of a sense as to what's going on. And you can kind of use the yardstick of, like, if it generates tons and tons and tons of code on the right-hand side, then probably it's more expensive than the one that just does add, although that can be misleading. So that's what Compiler Explorer is. And apparently one person said they didn't know what it was. So we explained that.
So why is this? Why can't I just do that with my compiler? I mean, I look at the code it generates. Why can't I just? I mean,
absolutely. And that's
what's the advantage to using this?
So yeah, the main advantage is the immediacy of being able to try out all the different compilers that I have on the site. And it does a whole bunch of filtering. It prunes out a bunch of like redundant opcodes and, or rather labels and things that aren't actually used, so that hopefully a small little program on the left-hand side amounts to just the things you need to see in order to understand the code on the right-hand side. So while you can, in fact, use GCC, and in fact, behind the scenes, that's exactly what's happening. It's just compiling and then disassembling and playing around with that. It does add a little bit of extra value, the colorization stuff, and the fact that it's doing it continuously while you're typing. So in fact, the original version of Compiler Explorer was a tmux session on my terminal, with one side with VI of foo.c, and on the other half of the split terminal was just the Unix command watch, which is awesome. It just like runs the same command over and over again and highlights differences, with like then a giant line of GCC minus E, blah, 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 or sorry, minus cap S, and then like a pipe through C++ filp, pipe cut, and like basically this giant Unix pipeline that generated essentially what Compiler Explorer does behind the scenes. And that was really, really powerful. And it came up out of a discussion when a colleague and I, if I remember rightly, were discussing whether or not the newfangled, this was 6-7 years ago, range-based fors were actually better or worse than just going for in I equals 0, I is less than vector.size. One can't help, if one's spent a bunch of time like trying to make things go quickly, that thinking that what could be faster than getting the size of an array or a vector and iterating over them by index. You know, I'm smart. I know that that's going to just mean these instructions in the instruction stream. And so why on earth would you use this newfangled range thing? Who knows what it's doing? And maybe part of that comes from like bad experiences with other languages where range-based fors generate iterators that generate garbage in, say, Java. Or maybe it's just, I don't know. But it was one of those things where we were like, well, maybe we should have a look at this. And then it was really difficult to kind of work out because you edit some code and type make, and then you try and look at this giant disassembly of your entire program, find the bit where it was, and hope that you could sort of tell whether it was better before or after. And then we wrote the little shell script, and then, yeah, we were like, oh, actually, it amounts to the exact same code. So cool, this is awesome. Now I can use these new features, and I can be certain that I'm not making my program slower.
Right, which was part of a big part of what Jason's point in his plenary at CppCon was to say, here's these cool new features. You don't need to be afraid to use them.
Right. I mean, and Jason's was an awesome demonstration. Sorry, Jason, you got us.
No, that's all right. Go ahead if you had something else to add here.
No, I just thought it was amazing. I mean, my other hobby is resurrecting old computers by writing emulators for them in JavaScript. So like, it was Jason's keynote was like the most amazing confluence of the two things that I'm most passionate about, which is assembly and understanding C++ and old hardware. So you should definitely watch his video if you haven't already.
That was a really fun one to do.
And
I was going to say that I actually use Compiler Explorer basically several times a day, every day, all day, pretty much. Whenever I'm playing with some technique that I don't know if it's going to work or what kind of code it's going to generate, I just type it in Compiler Explorer because I'm like, well, I have no idea what I'm doing. So I'm going to start typing and see what compiler errors I get back. And then I also have the advantage of knowing how efficiently the code is compiling.
Right. It surprised me how varied the uses are of Compiler Explorer. I mean, I predominantly use it, or at least did use it for like, how can I optimize something, or at least visually generate code that looks optimal to me quickly. But then, like you say, it becomes quite a useful work pattern to just be able to paste into something and just see the code output without having to fart around with remembering the compiler settings or which compiler does what, or make files and stuff. And I think the barrier to entry for that is very, very high in C and C++, whereas other languages, like, hey, Bash, if I want to do something quickly, I can write a Bash script and it just works. It's just there, it runs. And I think it's easy to underestimate how important kind of that REPL feel is in languages. And C++ has never really had one that, and maybe it doesn't make sense to even have one. I know there have been some like REPL-like attempts around, but it doesn't lend itself very well to that idiom. And so you're not really encouraged to experiment and play. And I feel that if you're learning something, it's really important to be able to do that, to have that kind of hands-on feel that like, well, what does this change? What happens if I delete the destructor? Oh, that's interesting. Those kinds of things. I mean, like, there are a whole bunch of like move semantics or return value optimization stuff that either disappears or reappears depending on like other things that you've defined. And I mean, yeah, Jason, you're much more au fait with the language as such, but I do remember having to at one point implement two I think either operator equals and also the copy constructor for something just to make RVO happen, even though they were never actually called, or there's something weird thing like that. Maybe that
might not be true in C++ 17 with guaranteed copy elision now.
Right. Okay. See, this is why we have you for chapter and verse. This is much better than my kind of hand waving. I don't know. I mean, I'm just an assembly programmer at heart who's kind of begrudgingly seen C as like, well, this is a step up from assembly, and then kind of gone, well, it is convenient to not have to worry about these other things. RAII and stuff comes from C++. This is brilliant. Okay, we'll take that. But my heart, I'm still not very good at the actual mechanics of the language. But
right.
Yeah.
I do appreciate, because I write a certain amount of code in Python, and the ability to just go out to a shell and just type in Python and then start playing with things, because I will do that. It's like, well, if I do this, does that change the original list, or does it make a new list, and how does that work? And yeah, you just play with it and try it out. And yeah, the ability to do that's very nice. And it's kind of a non-trivial for C++ to say, oh, let me really quickly check that in C++, and there's a certain setup involved.
Right.
Well, you mentioned that REPL fill. When can we expect to be able to get output from the executing program?
That's a very good point. So that has been on the feature list for a long while. and it is going to I'm definitely going to get to it sometime, probably summer this year. The rate things are going. I think it's worth saying other online compilers are available. There is Wandbox is one, and there's the one that's linked off of this CPP reference website, which may or may not be the same thing. There's also one that uses Visual Studio as a backend. So it's kind of like regex tester or something like that, which is bizarrely used to be just for regular expressions in C# or something. So there are other ones, and those guys guys, listen to me. Those sites do actually execute the code. And oh yeah, Colliru, people are putting in the chat here various other things, stacked and all sorts of different things, so and Cling and things. These sites do compile and then execute your code, and so they're really good for this. But they don't have that REPL feel. They don't like dynamically do it. You have to kind of press a button, and certainly in my experience of using those sites, limited as it is, with my huge bias that I have, they don't seem quite as interactive to me. They feel like you press a button and then your batch job has been submitted and we'll get back to you when it's finished, which is totally understandable. I mean, there's a lot of fun and games behind trying to make it vaguely responsible.
I will say that I love CPP reference for that, to be able to just go in and make a little change and say, well, what would happen if the feature was used this way or something like that. That's the killer feature when I show other people. I do in my classes and other times I will say, well, we use CPP reference for our online reference, right? We don't use those other guys. And everybody says, oh, we're not supposed to use the other guys. And I say, well, let me show you why. And I first of all explain it to Wiki. I say, you know, that's why it stays timely and it's updated and it's accurate, because it's a wiki and everybody contributes and all that stuff. But let's look at sample code. The other guys have sample code too, but let's look at what we can do. And it's, you know, when they realize what's really going on, it's like, you can do that? That's kind of cool. And
I have
then,
to admit, I've never used that.
But that's not showing you the assembly levels.
Yeah.
Oh yeah, that's just very nice. Although if you're used to using Compiler Explorer, then you've got that right there. So, you know, but as I say, it is the killer feature of CPP reference that you can make the change and you can watch and see what it runs.
Right, which is, I think, you know, certainly for those who are less familiar with assembly code and are less interested in the assembly code as such, we really wanted to say, what does my program do? Not what does it look like in terms of assembly. So yeah, so in answer to you, Jason, yeah, it will be coming soon. I'm currently working on a whole bunch of UI improvements, which you can follow along at the beta site, which is gcc.beta.godbolt.org. You can go and play with all the features there. I've just broken a whole bunch of things and filed a whole bunch of bugs against myself. I don't know, is this a common pattern for other people? I find myself, because I have like a whole bunch of branches, I not only am filing bugs against myself, I'm also in merge conflict hell with myself most of the time. And I got this strange sort of, I just wonder if that's just me. I think it's just me. But yeah, so the UI stuff is coming along. We should be, that should be out in the next month or so. And then the next thing I'd like to work on as like the big ticket item would be to execute the code, which, as you can imagine, executing arbitrary code that people have just typed in onto a website is fraught with security related issues, of which Compiler Explorer has already had its fair share of somewhat half-hearted hack attempts, but hack attempts nonetheless. Turns out a compiler is a very, very large target for generating arbitrary like buffer overruns and stuff. You know, the things I've learned about GCC in particular, you know, like you can just specify plugins, of course. So if you can find a way of compiling code and leaving the .o file or the .so file knocking around and /tump on my machine, you can then use it as a -f plugin in the next compile line, and then you can start injecting arbitrary code into the compiler. And then you know, it's the people who dream this stuff up. In security is hard. It really is. So please don't hack me.
Well, security is not hard as long as you don't actually expect to make a usable system, right? I mean, the reason that security is hard is that we really, you know, that's a feature, right? That you can do that. And that's the point, is we want usable systems, and then it turns out that then if they're usable, then they're misusable. And that's just the way it is. I did miss an opportunity earlier when you were talking about how much you enjoyed Jason's talk to point out that if you actually were to attend CppCon, and I'm just throwing that out there, but if you were actually to attend CppCon, you wouldn't have to watch it on YouTube. You could actually be there live and see the magic in person. But I'm just throwing it out there because I think contractually I'm obligated to do that as conference chair. I just have to say.
You can also heckle the speaker if you're there live.
That's right. That's right. If you're watching him on YouTube and you make fun of his using Commodore 64 instead of an Apple II, he never hears that.
Well, you know, We can talk about old hardware as long, but both of you are wrong, obviously, when it comes to 6502 based early home computers.
You're an
So
Atari guy.
Oh.
oh no, I'm British, so it's the BBC Micro for me.
Oh, of course. I saw your video. Of course. BBC Micro. Oh, of course. Yes.
Yeah.
You know, the only real assembler I've ever done is on 6502. So I enjoyed your video talking about 6502. And it's like, oh yeah. I can't remember. I don't remember actual opcodes, but there was a time when I could give you the my first experience of assembler. We literally did not have an assembler, so we wrote everything in assembly, and then we hand assembled it.
Right.
So yeah, I knew all those opcodes at one time pretty well.
So my first computer was actually a ZX Spectrum, which was I think it was called the Timex over here. It was a Z80 based thing, and my very first assembly program was written while I was at a swimming gala on the back of the program by hand and assembled by hand from memory, and then typed in when I got home. And I was amazed to see that it worked. Which is like, and it was a little scroll text thing along the bottom of the screen. It was, it's joyous.
See, I thought you were gonna say it was like a ray tracer or something.
Oh man, what, an 8-bit machine? That would be fun. That would be cool. Yeah, no, nothing that sophisticated, I'm afraid. I was only 12, I think. So we're, yeah. Anyway, enough about that. So Compiler Explorer execution.
The other thing I want to say.
Okay.
All right. What I was going to say is the other thing I want to talk about was CPP Weekly. I watched an episode or two a long time ago and enjoyed them, but I didn't really get in the habit. And now I've watched a few more when you were talking about lambdas, and I suddenly realized, first of all, you've got an awful lot of them. Secondly, they're very short, which is a real, it's not like this show where I just keep talking and talking and talking. No, it's short, it's to the point, and it's fun to follow. The criticism I had, which is what I already leveled at you, is you because it's short, you're building on what you've done before. And so if you just start in the middle, then it's like, oh no, this is based on this one. Oh, you got to watch that. But that one turns out it was based on the one before it. And so we need to have a dependency tree relationship on your website to say, if you want to watch this video, you actually have to start back here and then watch these two, and then you can watch it. Even then, it's still only going to take you 15 minutes to watch 3 videos. So it's not like it's,
Well, that's an interesting point, John. When you first mentioned that to me, I'm like, but what's a great way to represent this? Because if I have links back, then when you start the video, you're still like, oh crap, I have to go back. Oh, I have to go back. I have to go back. But if I actually had like a tree graph of how all of the videos interrelated to each other, because at this point I've done like 10 videos that relate to lambdas, for instance.
Yeah.
And I've done like 20 videos that are C++ 17. And of course there's overlap in those things.
Well, so there's difference between related and actually building. I mean, when you did the Lambda one, you said, okay, here's the code that we ended up with in the last video.
Right.
And that's what I wanted to do. If you just said, by the way, if you want other 17 features, here's these other 3 videos you can watch. Well, maybe I'll get to them. But if I'm watching something now and you say, this is where the code came from, then I'm really likely to say, no, I need to stop this right now and go back and watch that. So there's difference between what's related. And I think when we were talking earlier, you mentioned playlists, which makes perfect sense to say, oh, here's all the stuff related to 17, or here's all the stuff related to lambdas. But there's a difference between that and actually what I think of as dependencies, which is to say, the code I'm showing you is the code I developed back here, or to address the use case from back here. And so that's a little different. And
right.
And particularly since the videos are fairly short, you kind of want to do that rather than. I mean, I've seen like conference videos where someone said, well, part 1, you might want to watch that, but this is a little bit different subject. But part 1's an hour long, and maybe I really just want to watch this one.
Yeah, so they tend to be about 5 minutes long, like you said. And you said I've published a lot. That was my 50th episode that you last watched. So I am 2 away from having done this for 1 year. I have not missed an episode yet.
Wow.
Time is
I did that for 11 weeks. So I know how hard that is. I know how really hard that is. Somehow life interrupts.
Yeah.
And you were really sick the
you
other
can
week.
do it.
Jason was really sick the other week, and somehow you still struggled through and made an episode. You really have kept to that. It's very, very impressive.
Well, part of the key is that if, things are going well and I have time and not too many distractions in my life, then I'll tend to like sit down and record like 4 episodes at once. And then that helps me to have a buffer for if I do get ill or we go on a road trip or something like that.
Yeah, yeah. Do you ever do that with CppCast? Are you guys have some in the bag or anything?
We never have any in the bag with CppCast. We want to make sure all the news and everything is timely.
Yeah.
But I mean, we've
I'm
like
really impressed.
once done that actually, but
Generally speaking, they come out on Friday and you've recorded them on Wednesday or something, and
Yeah.
that Rob turns those around so fast.
he does turn them around very fast. Sometimes I'm impressed too when I see him publish it, sometimes just a few hours after the recording, depending on when we did things.
Yeah, yeah. Well, I
Yeah.
do the same thing here. The difference is I don't do any editing at all. I don't splice in any, there's no commercials, there's no editing. It's all, in fact, there may be an 8-minute gap on this one. I don't know. We're going to find out.
Yeah, one of the things that changed in my routine recently was after I first found out about Jason's podcast was to actually install a podcast app on my phone and subscribe to some podcasting, this one included, and then on YouTube as well, subscribe to C++ Weekly, and it has really changed how much up to date I am with things that are going on in C++ and ideas and stuff, because I think most people have at least a small commute to work. I mean, maybe you two working from home, perhaps you don't have quite so long a commute, but I have a half an hour a day in each direction, where if I'm not hacking on Compiler Explorer, then it's nice to have something, and podcasts seem to fill that gap beautifully. And I think the only downside to C++ Weekly is that when I'm walking down the road holding my phone walking to the train station, I'm in danger of walking into something as I'm trying to squint to read the code on my tiny little phone.
Being mugged or something.
Yeah, that's right. Yeah, you can be jealous of my commute, because I work out of my home, right? Except my next job is in Vancouver, Canada, so I'm going to be commuting across a national border.
Oh,
so yeah, it has some nice commute advantages, but there's some downsides to it.
I don't know the commute. So I used to live and work in London, and the commute there was pretty nasty, but again, it gave me that kind of time box time for like, well, this is me time, and I'm either reading a book or I'm listening to music or something like that. There's nothing else to do. There's just staring at other people on the train as it's going. Here in Chicago, it's a lot more. The commute's a lot more easy on me, in fact, because the seats are bigger and stuff, and that means I can get my laptop out and I feel comfortable doing so, which gives me like an hour a day almost of just pure hacking on hobby projects time, which I think I would miss. I don't think I would be able to give myself the same level of like hobby coding time if I didn't have that. And in fact, we not that long ago moved a little bit closer in towards the city, so I lost like 10 minutes each way on my commute, and I have noticed the difference in my productivity.
I can honestly say I've never wished for a longer commute, but the way it works in Denver and where my house is situated, my, like a 30-minute drive would be like a 2-hour commute on public transportation, at least because of where I live. And that is not worth it to me.
Right. Well, I have a huge podcast habit, and audio podcasts only. That's why I haven't really been watching Jason's, because I don't really do video stuff very much, because I think that's a huge, and the audio podcast was because here in the Bay Area, I would have a minimum of an hour commute each way every day. And so now that I don't commute anymore, I really have to, I'm listening to a podcast if I do anything. It's like I'm brushing my teeth, but I'm also listening to a podcast because I need to. I just have this huge subscribed list of podcasts that I listen to, and I listen to them all. Well, with the exception of CppCast, I listen to them all literally at 2 times. Because I've found out not only does you save a lot of time, but what I found out is that at first people are like, "How can you listen to that? It sounds so weird." But it turns out that your mind wanders less. We can hear faster than we can speak. And so if you just listen to regular podcasts, then pretty soon you're thinking about something else, and then you realize, oh, I don't know what he's been talking about for 5 minutes. Whereas if you play it at twice the speed, it's more engaging. But the reason I don't play CppCast that fast is because there's enough technical stuff going on that I can't process it that fast. So I don't mind slowing that one down.
Right. Yeah, I listen at 1.5 1.5 speed, and I was only saying to Jason the other day that like when we next speak, like we are now, I'm gonna be surprised at how slowly he talks. But it's just because you're used to hearing it, and every now and then you have to remind yourself that you are listening to your podcast at like 1.5x, and yeah. So we've got a few things going in the chat, guys. I wonder if we should talk about some of the stuff that. Please.
Well, we should also talk about CppCast. You had
yes.
STL on, and a phenomenal guest. Wait a minute. Did we talk about STL last week? I know you had Alan on, or Alex Elaine. Is that his name?
Elaine? Yes.
From cprogramming.com.
Yeah, that should be the episode that just aired.
Yeah. Right. And I love that he's built up a community. I wish that there was an updated version of his book, because it's a really good book, but it's really for, it came out in 2012, and he made the right decision, which was at that time to not focus on 2011 because there wasn't really enough compiler support for it then.
Right.
But now it's time for an update.
Well, that's an interesting.
And he
No, go ahead.
I was going to say, he also addressed a part of the market that I'm interested in, but haven't done. Mice training, the typical thing over my training is I'm taking intermediate programmers, kind of getting them to advanced. That's what I focus on. And it's largely because corporations aren't going to bring me in to talk to beginning C++ programmers, right? That's just, generally speaking, they're hiring somebody who's had at least some C++, so they're not beginners. And in the book that he wrote, he was focusing on, and I understand this, if you're looking at trying to program in C++ for the first time, what compiler to use, how do you edit the code, all these kinds of details. And fortunately for me, I never talk about those things, because it's just an assumed thing that you've figured all that stuff out, and I don't have to go into that. And one of the things that I've learned in training is, let's suppose I want to have an exercise in my training, and I just have everybody write, okay, everybody write hello world, let's compile it and run it. Well, that's 20 minutes. That's a minimum of 20 minutes, because people who came in, even if you told them, have your compiler set up and ready to go, well, they didn't really, thought they did, but no, there's this thing they have to do, and then there's this other thing, and oh, that's on my desk machine, but this is my laptop, so I got to do this, And I kid you not, writing hello world is going to take 20 minutes of real time. And that's why a lot of I don't do exercises. I believe strongly in doing exercises during the class. But if we have exercises, we will literally cover half as much material, because these little tiny things that have nothing to do with how lambdas work or what's in C++ 17 or any of those kinds of things, but the real world problems of, oh, where's that data file again? And
that's where something like I think Jason uses VMs for some of his stuff, and then things like Docker containers, which are are all like newfangled, and everyone wants to overuse them. But it's nice to just say, here is a little hermetically sealed unit that I just know works. I'm going to give it to all of you, and you can do whatever you like in that world. And I know that it's all going to work. And it won't have your editor, it won't have your key bindings, but it will compile code, and you will be able to get on and do something useful. I think that's another thing that like C++ in general does suffer from. We talked about how hard it is to get started, which this is a sort of special case of it. But because there is no well-defined way to bring in packages and note your dependencies, it's very easy to get into a situation where you've written some code that, unbeknownst to you, depends on some boost system header that comes from some apt package that came from your previous computer that you copied over, but you didn't realize that it came, and all those kinds of things. And then it can be extremely infuriating to as you say, to try and sort of say, okay, well, let's see what you're doing now. Let's try it on this computer over here, and then go, well, why is this not working? And you spend 25, as you say, 20 minutes just trying to find which esoteric package you're missing. And yeah, I think that we could probably do better. Everyone keeps talking about Conan. I haven't yet looked at it. At work, we have like a system of binary package management, and I'm extremely fastidious about making the compiler itself part of the dependencies of the project. So in theory, anyone should be able to take any machine and just git clone the repo and type make, and it pulls down all the dependencies, including the compiler and everything that's needed by the compiler, as like a hermetic blob. And that kind of thing, I've had people give me feedback about how useful it is, even within the company, for just another team to be able to pull down my code and just type make. And it's amazing how few people think that that is achievable or worthwhile. But CMake to an extent is making that more of a open to all. And maybe as time goes on, more and more projects will be like that. But the whole like /configure, oh no, I'm missing stuff, or what do I need to do? Read the readme.compile, and then like look at all the dependencies you need. That's a real barrier to entry to sharing code and to allowing people just to dip in and dip out.
Yeah, at one point, the closest I got to what you're talking about, well, I mean, I've done Packer files to build the entire environment from scratch, and that's its own level of pain, depending on what operating system you need to support. But I have made a dev Debian package that all it was the dependencies that you needed to build the project.
Right.
So very high level thing, nothing in it, just dependencies. And that was actually proved to be pretty useful when setting up a new environment also.
That's pretty cool. The drawbacks with that is oh, go on, John.
I was going to say, early in my career, I worked with an engineer who had worked at Fluke. And if you aren't familiar with them, they make like robots and stuff like that for assembly lines and a lot of automated kinds of things.
And
he told me when they, what's that?
And testing tools. Fluke makes multimeters, that kind of thing.
Yeah, I think it's the same company. Anyway, he said when they archived a project, they archived the hardware as well. So you literally were guaranteed that you could rebuild, because they're in a world where, oh, you don't know what processor you're going to go on, you don't know what, and so just saying, oh, I want this compiler version, just download it and you can run it on any machine. They couldn't be assuming that any machine. So their archive actually involves physical machines as well. It's like, here's the machine you can use to build it on, and it's configured, and here it is.
Wow.
Wow.
That's just a shame, really.
But now we have VM.
Yes. Oh, now we do that thing we're all talking
yeah.
to each other.
Well, let's see. Is there another topic? I think you were about to get us to a new topic, weren't you, Matt? About
I was just saying that there was a few things in the chat. I don't know about you, but I haven't got like the YouTube itself open. I've only got the Hangouts that we're currently talking on. But Adi was saying that there's a question on the live chat about something I did way back on the optimizations of Agnafog, who's, I don't know if you guys know who Agnafog is, but he's an absolute legend in like the optimization community, certainly, in as much as he has taken it upon himself. And I think if you go to his website, which looks like it comes from like the late sort of mid 90s kind of era of HTML, I think he's a professor of something really like comparative sociology or something like that, but he has taken it upon himself to reverse engineer every Intel processor that's ever come out and sort of document it in astounding detail. And I believe that it's used, but then by compiler teams themselves to then work out how they should emit the code to better take advantage of the new hardware, as well as like people like me who are trying to then write code that fits well to the software. So the question was, how am I with the Agnafog optimization? So I spent a whole bunch of time taking Agna's original code for like that he used to reverse engineering which pipelines are used on which Intel instructions. And I've got a GitHub repo now, which kind of has sanitized it and made it build on more modern hardware. And I was using it about 3 or 4 months ago, maybe more than that, to try and reverse engineer the branch prediction system of x86. And I guess the short answer, and I'm having just talked now for 2 minutes, is that I haven't got any further with that. Life is called, and there are far too many irons in the fire right now. But it's something that I am very, very, very interested in. And I think it interests all of us really, like how the actual metal works underneath what we do.
Yeah, it's still the kind of thing that I'd prefer I let the compiler writers worry about more for me.
Right, but I mean, there's some interesting things. So my sort of poster child for at least having some understanding of the term I've seen pushed around for this kind of thing is mechanical sympathy, the kind of understanding that you are doing something, but deep down, there are some mechanical things that are doing the work that you're asking of them. And if you know how those work, you can take advantage of it even up high. Branch prediction and things like that will kind of fit into that cache coherency stuff. But things like on an Intel CPU, you can issue like somewhere between 3 or 4 instructions per cycle. So your 3 gigahertz top end machine is, it's got 1/3 of a nanosecond per cycle, and it's doing 3 or 4 of them at a time. It's an astounding amount of work that can be done. And yet an integer divide operation, for each CPU core, there is exactly 1 divider. And that divider is not pipelined or pipelinable even. Well, it's partially pipelined, but it means that if you ask for the result of a divide, it's going to take 70 or 80 cycles before you can get the result out, and you can't do any other divides while that's going on. It's not like there's one each cycle like the multiplies or the adds, things like that, and they just pipeline and end at the same time. And the only reason that's important is because everybody's favorite container, if it's not a vector, which is a pretty good start, is an unordered map, or at least it is in my world. And an unordered map, of course, has a hash map underneath, and the hash map needs to do a modulus. And if you know ahead of time, if you're writing your own container, if you know ahead of time how many buckets you're going to have, you can use a constant, a compile time constant, to divide by. And the compiler is smart enough to know that divides are expensive, and it does effectively an integer reciprocal multiply trick to get rid of the divide and turn it into a multiply. But if it's a variable, like it is with an unordered map, because it may size up, then you're condemned to having a modulus in there, which is effectively a divide. And that means that if you the fastest you could possibly hope to look up in an unordered map is of the order of like 80 or 90 cycles, which sounds little, and it's amazing. But if you were to say to accept, like, well, I'm just going to have a power of 2 sized container, like a vector or whatever, and I'm going to do a hashing myself and fall into it, then you can just pick off the bottom few bits. And of course, you don't get all the lovely properties that they talk about in your computer science classes about, like, the fact that you're going to get perfect or as near to perfect usage of your container. But maybe you could spend a few more cycles on your hash function and use one of like murmur hash or something like that, which of course is big and complicated and many, many cycles, but they're all adds and zors and ors and adds. And then you get a better hash, and then you just take the bottom few bits off, and then suddenly you've got a very fast container. And and again, there's no amount of compiler trickery that can do anything about that. You've just written code that just can't really go any faster than some relatively I mean, it's insane to think that you can do a divide in 70 cycles anyway. I mean, that's just crazy. That's like no time at all. But for the type of stuff, certainly that I do, that's the kind of thing we're thinking about. And I think you need to know a little bit about your CPU just to have an appreciation. And again, cache effects are another thing. If you make a big giant structure full of wasted space, then you could potentially make it faster just by reordering your structure elements and things like that. So yeah, I'm very passionate about it, as you can probably tell. I love this stuff. It's really, really cool.
Might be worth mentioning too that these older CPUs, like we were talking about, the 6502, didn't even have divide and multiply operations.
Right. Yeah. It's quite crazy when you do speak to people that are, well, how did you do it then? And, well, how do you multiply numbers together yourself? If I were to give you 2 like 3-digit numbers and ask you to multiply them, you do it. You say, okay, now I'm going to write it in binary. Let's do it again. And they're like, oh yeah, you can just do long multiplication in binary. And that's how it works. That's how you do it. We're done. But it's awesome, isn't it?
Yeah.
And it's also
multiplication is not that hard, but division's a pain in the butt.
Right.
That's the one that's like, oh, this is no fun.
So the and the other interesting thing about those old hardware as well is it was in sort of the amazing time when memory was faster than the CPU, which, so for example, on the BBC Micro, the memory ran at 4 megahertz and the CPU ran at 2 megahertz. And that meant that the video circuitry, which was generating 8 pixels every clock tick, could read it on one cycle at 4 megahertz. And then it offset by like half a phase, the CPU would get to look at the memory. And then, that's just mind boggling now that the limiting factor was the CPU and not the memory when it came to these kind of operations. But
yeah, and the display circuitry had to run at like 4 times the speed to even be able to push the pixels out fast enough to the TV.
Right.
It's nutty.
It's really worth looking into those things. That's why it fascinates me. And I mean, part of it is because when I was a 10-year-old and I was hacking this kind of stuff together, that it's nice to revisit those days and enjoy the sort of reminisce over old times. But there are some really interesting tricks that were done at the time, and there are some fascinating things you can do when you really dig deep down into how the system works.
So while we're reminiscing about 6502 systems, there was a technique that was developed by a guy named Don Lancaster for the Apple II, and he called it vapor locking, I think. But the Apple II had this had a number of different video modes. So there was a text mode, And then there were two different graphics modes. There was one that was high-res graphics and one was low-res graphics. And the low-res graphics was effectively what would normally have been a character could now be effectively a pixel of whatever color you want. So you could have lots of colors. In high-res mode, you only had like 6 colors or something. But anyway, what he figured out was that you could actually, because the video circuitry was reading from memory, you could actually figure out where the video circuitry was reading last. I mean, because the processor is running faster than the video scan, right? So there's a scan process going on to read memory and display it. And what he effectively did, I should say this also, the Apple II had this interesting thing where you could have high-res video on the top and then like 4 lines of text on the bottom. And people would use this for like adventure games and things like that, where they would show a graphic and then at the bottom there would be the text and you could type that in. But you had no choice. You were in one of these modes. And if you wanted to do graphics and text, then the only way to do it was exactly 4 lines of text, exactly at the bottom. Right. But what he figured out was that if you could figure out where the video scan was, and you could arbitrarily flip the video mode, so you could end up deciding, oh, I would like to have text in the bottom half or text on the top half, and I'd flip the video. Now, of course, in order to do this, you had to, I mean, it was processor expensive because you had to be constantly querying to figure out where the video was doing it. And it was all based on the fact that if you read, you could actually read the address mode because that address was still on the bus. And so that's why he called it vapor locking. And of course, Apple immediately released a thing to developers saying, do not do this. We are not promising this works in the future. This is completely, completely undocumented and should not work. And I never saw anybody do it in like a professional game or anything like that. Because I think, like I said, the overhead of the one really cool thing that would have been nice on an Apple II that you didn't have is there was no way, there was no interval counter. There was no interval interrupt.
Right.
You wanted to time
I was going to say, on other technology around the time, that was exactly what you would do. You use a counter to generate an interrupt, and then you would change the palette, or you change the mode, or you do other tricks like that. And it's very common to do that on those old machines.
And with an Apple II, you could not do that. You had to know how many instructions you had executed, or I mean, in fact, that was one of the things that totally freaked me out. The first time Apple released an Apple II machine, I knew a little about the 6502. As I said, that's the one machine I actually knew anything about as far as assembler. And you were talking about how the BBC Micro ran at 2 megahertz, and the only 6502 I ever used ran exactly at 1 megahertz, and that was that's what the cycle is. And instructions were multiples of 1 megahertz, or sub multiples, whatever. But the first time I heard that Apple was releasing a machine that ran with a faster clock, it was like, wait a minute, games aren't going to work anymore, because games are all dependent on not how fast something actually happened in the real world, but on how many instructions were. And sure enough, you run the game on this, and it would just run twice as fast, or whatever the clock speed was, because there was no way to. You couldn't, with an Apple II machine, you couldn't have, of course, even memory or anything else, but you couldn't have run a concurrency kind of thing. There was just no way to do an interrupt at all.
Right.
On it.
Yeah. The BBC, sorry, this is getting completely into old hardware here, but the BBC Micro had most of its peripherals, for the same reason the Apple ran at 1 megahertz, almost all of its peripherals ran at 1 megahertz. So all of the hardware associated with, or the memory areas associated with the hardware ran at 1 megahertz. And there was this complicated bit of circuitry that effectively just halved the CPU clock speed when it was accessing those peripherals only. And so there were even more complicated effects about, like, the fact you're running at 2 megahertz, and it jumped to 1 megahertz and then back up again. And of course, games would take advantage of this, copy protections would take advantage of it. I've blogged about this to death on my website, so if you go and look at, if you want to know more about it, there's a load on there. And also I think I mentioned it in passing on one of the videos you alluded to earlier, but yeah, it was a lot of fun. I mean, you don't have that level of understanding of a device anymore now. I mean, even like on an Intel processor, you can open it up and look at the stream of instructions. We've just been talking about, like, how long a divide takes, but you know that's the API effectively to the CPU. And as soon as it gets remotely anywhere into the silicon, it's turned into something completely different and executed a completely different way anyway. So the things that you can infer nowadays, I think we've had the time when you could understand a system and have dependable speeds or understanding exactly how long things are, determinism, that's what I'm looking for, is gone, which is kind of sad, because you can only you can optimize as much as you like, but for all you know, a minor chip revision might change the way things are done in a way that actually has an impact on your code's progress.
Charlie Bay, is that his name? I believe gave a talk at C++ Now 2016, and he gave it again at CppCon 2016 about how we have no idea what the CPU is doing with the instruction stream we give it, and we should be okay with that.
Yeah, I mean that's
we have to be okay with that. I mean, if you're not okay, it doesn't matter, because that's not the case. But you're absolutely right. I mean, the hardware should document an interface, and we should write to that documentation. So I think Jason's trying to show off a T-shirt there, right?
Yes,
oh, yeah, already got that there. I'm also just stretching my back a little bit here.
Yeah, no. So back to sort of the point about Agner Fog, that's his sort of life's work, is to reverse engineer that side of things and document to some extent what really is going on inside the CPUs and how clever they are. I mean, I described it as almost like a JIT. And certainly the most modern ones have all these layers of caching beyond even just the instruction cache. It's like, well, I cache the intermediate results of this stuff, and it's absolutely fascinating. Absolutely fascinating.
Yeah, but I think you're right in the sense that you have to have, I think, what did you call it? Mechanical sympathy? I think that's the name of our show today, is mechanical sympathy, where you want to understand what the compiler is doing or what the hardware underneath is likely to be doing. But they don't want to guarantee it because they might come up with a better way in the future. So you just kind of have to think this is probably hardware friendly and go with that.
There's a whole set of algorithms that are known as cache oblivious, which is to say that they are designed such that they don't take advantage of a particular size of cache or a particular layout of cache, but they are designed so that they are effective on whatever size cache you have. Huh. And so that's a sort of Googleable term for finding some of these more interesting algorithms. But yeah, that sort of speaks to mechanical sympathy without necessarily knowing the exact hardware you're running on.
We keep talking about algorithms and some data.
We didn't really talk much about C++ today, did we? I'm sorry to all those people that are in the background waiting for us to go and talk about templates or other things like that. But,
Variadic templates, I believe, is the word of the day.
Is that the new cool thing?
Well, normally I think the show attracts people who are interested in the very latest in C++, but I think this particular episode has just attracted Compiler Explorer fans.
Right.
So I think we may be forgiven this time.
I hope so.
Well, so John, right off of your right shoulder, I can't help but notice 3 volumes that are very distinct, and I don't know if any of the other viewers have seen this.
I noticed it earlier, actually. I was going to ask him myself.
Do you know what I'm referring to there?
They look like,
I'm not sure. You're talking about
the Knuths, surely.
Yes.
Those 3 different volumes of the same beige with the different colors. And I mean, we've been talking about algorithms and data structures. I'm wondering how often you pull them off the shelf, and have you read through all of them? I know that Matt has.
But I'm weird.
I don't use them as often as I should. Well, I don't need to as often as I should. I'm not writing big, complicated things. I'm really interested. There's a talk at C++ Now about sorting. I've always just assumed sort was n log n. That's what I was taught. Sort is n log n. But we have a talk at C++ Now. Well, it hasn't been accepted yet, so I don't know that that'll be. I certainly hope it'll be accepted.
Spoilers.
And I guess I should announce about status of the conferences. And most of the things going on for CppCon I can't talk about. But C++ Now, the reviews are in. And Bryce, the program chair, and I and some other people are looking at, what's the schedule going to look like. Well, unfortunately, we haven't locked all the keynotes, and until we know exactly how many keynotes, we don't know exactly how many slots we are. So we're in this really interesting situation of not even knowing how many we can accept. So I don't know if this will be accepted or not. I certainly hope so, because I want to see it. It's a talk on radix sort, which is less general than the sorts we use that are in login. However, if you look at it, the requirements on what you can do are pretty general. So most things can be converted into something that can be used with a radix sort. And you can get speed improvements if you can do that. So, so if you're interested in algorithms, well, of course, if you're interested in algorithms, I assume you're already going to C++ now, right?
So just briefly on the Canute thing, I know we're running out of time here, or wildly over time.
Oh,
but the thing I love about the Knuth books, sorry, my son is now just hiding off my shoulder over here. The thing I love about the Knuth books is that they are, of course, extremely detailed about the algorithm, and they're very high level at that point. But then Knuth implements them all in his own processor specific stuff, including like this almost like childlike, well, I can game it by using the plus bit to mean something clever, so that when I'm doing my red-black trees, I can use this bit to mean this. It's like he's packing his data and everything. It's just, it's so awesome. And the fact that it's simultaneously both low level and insanely high level just appeals to something in me, maybe even is a reason why I've ended up going the way that I have done from reading it.
Well, I think we do need to wind up. We didn't get to talk about John Rager's blog post on undefined behavior, but we'll have to maybe leave that till next time, or we'll probably have some interesting things too. But I'll let you guys, if there's anything you want to say in parting.
I don't think I have anything to add.
No, the only thing I could add would go on for about another 3 hours, so we should probably stop and do this another time.
Well, I want to thank the chat room on the Slack for their patience and understanding about our false start. I still don't know exactly what happened, but I do appreciate them pointing out that we had a problem and giving us a chance to restart, so we appreciate that. And thank you guys, and I just want to say to you and to everyone, safe coding.
Safe coding.
Safe coding.
Till next week.